Hello, my name is Olivia Truenow. I am a senior biomedical engineering student at Western New England University. Today I will be talking to you about the design of a perturbation board to detect balance and instability. So the design team came up with a problem statement, which was to develop a perturbation board to be used by clinicians and biomedical engineers that actuates medial lateral and anterior posterior to quantify stability and provide a range of the change of center of pressure in athletes. We found that there's a very wide range of people who may develop a traumatic brain injury. Around 1.6 to 3.8 million people per year have sports-related concussions or recreational concussions, as well as traumatic brain injury, which is an injury to the brain with blunt force or an acceleration, occurs every 15 seconds. So in order to address this, we came up with the process. We followed the FDA waterfall process, where each time that we came up with a different design or a different input, we would go back to verification and validation. So we came up with some important needs, which was to have an accurate protocol, for the protocol to be done rather quickly, between 3 and 6 minutes, and it needed to actuate at a challenging level. So in order to develop specifications, we use a gold standard called the Biodex balance system, and we determined that they have a pass or fail, which we wanted to use. The test was only 4 minutes, and we wanted to have at least 15 degrees of actuation. From there, we developed a design. We had 2 designs. We had one design that required 4 actuators, and we actually decided not to go with just this design due to the fact that the actuators were having applied forces, and we weren't sure that the motors were going to be able to lift a person of a heavier weight. We then developed a rocking board system, and the rocking board system, we were concerned with the timing of actuators. We would have to have 2 actuators working on the same time, and it would be a difficult thing to program. Finally, we came up with the final design where we were able to do kind of a trampoline where the Wii board will sit on top of springs, and then it will move due to the fact that the actuator will hit a board that will be underneath, and that will be what produces the perturbation. From there, I want to discuss what my role was. I was actually able to build the board and build the frame around the board. And then from there, I also came up with what kind of spring constants you would look at for a kit that would be given to a biomedical engineer or a clinician. So I quantified these with a relationship between the mass of the client and how far that they wanted to go. And I found that the gray line that is pictured here would be the best trend to follow in order to get the most efficient perturbation as well as stability for the client on top of the board. From there, I was able to model the oscillation using those spring constants and to determine at different weights how far somebody might be able to go. I actually figured out that somebody who may weigh around 300 pounds or heavier would actually not be safe on our board due to the fact that it may not oscillate the same way other people would. So for the global impact, we want to think about the future implications. This would be great in a clinical setting where we can use biomedical engineers, clinicians to be able to test our product, IRBs, to be able to do clinical trials and such. From there, we would be looking to be able to maybe in a blue tent when an NFL player comes off the field to be able to test for a balance deficit there, as well as use this for physical therapy for people who may have Parkinson's or other movement disorders. So the more that somebody has a concussion, the more likely they are to develop CTE. So we want to be able to push ourselves to be able to use it in different aspects. Also, around 10 million people worldwide are impacted by Parkinson's, and around 60,000 Americans are diagnosed with Parkinson's each year, and there are thousands that go undetected. So we want to be able to have that demographic inside of what we are able to test. Thank you for your time.